Yeah, good evening, all. Myself, Dr. Praveen, Associate Professor in School of Computer Science and Artificial Intelligence, SR University. Now, today I am going to explain functions concept in our C language. In last video, I explained pointers basics, pointers with one-dimensional array, and pointers with two-dimensional array, and pointers with some programs like matrix programs. Sorry. Pointers with one-dimensional array, pointers with two-dimensional array. Now, today I'm going to explain the concept of functions. See, what is the function? Why we are learning functions? See, the function is a self-contained block which has contained one or more statements to solve a particular task. A function is a self-contained block. Statements. A function is a self-contained block of statements to perform a desired task. Okay, actually, what is the main objective of functions concept? See, friends, now when we are develop a project, in project, we actually in our previous programs, we have only 10 lines, 15 lines, 30 lines, maximum 50 lines program we completed. But coming to project development, we have to take the more than thousands of lines. So this can be developed by different people, not only one person, not only 5 people, or not only 10 people. Because this is developed with more than hundreds of people, right? So now this task or this project can be divided the modules. Now each module is called the subprogram or function. Okay, that's why it is called a self-contained block. Now this is your task. Now this task can be divided partition. Observe here. Now the circle is a task. This task can be divided partition. Now this partition is called function 1. This partition is called function 2. This partition is called function 3, swan function here. So that's why the definition of the function is a self-contained block of statements. Sometimes we have to take a function is a self-contained block which has contain one or more statements to perform a desired task. Now, how many types of functions in our C language? Not only C language, in our programming languages, we have mainly two types of functions. Now, that is called, one is the user system defined functions, system defined or library functions. And another one is the user defined function. Observe here, system defined function or library function. Now, in our previous programs, in our previous many programs we have completed, in all the programs, we use some input-output functions. Now, input function is the printf. Input function is the scanf. Output function is printf. Okay, now this can be again categorized. Right, one is the string handling functions, and another one is the right input out functions like printf, get ch, get char, get s, put ch, put char, put s. Many types of functions are available. Now these are all developed by the developer, not developed by user. Right, now these are all system defined functions. Now actually mathematical functions also we know, like absolute function, right? Okay, square root function, sphere function, power function. These are all the system defined. These are all belongs to the system defined function. Just here I mentioned two functions. Printf is the output function, scanf is the input function. So we take the get char, get ch, put char, put ch, put s, Yes, right? All string handling functions, string comparison, string upper, string lower, right? And next one is the string. Many functions are there. The all belongs to the system defined or library functions. And next, as a user, we have to develop our own functions. As a user, we have to develop our own functions. Like now, what is the program here? This is the program. Now this program can be divided module 1 to function 1 to function n. So each function we have to write the name of the function like I want to take F1, like I want to take F2. Now any word after we have a bracket that is symbolically represented the function. So now I am taking some examples. Display is the function, sum is the function, A is the function. Okay, this is user defined. User defined means as we wish, we take our own function name. Okay, now the steps to create the user defined functions. Mainly, we have three steps are there. One is the prototype of function call. You observe. First one is the prototype of function. Second one is the calling function or function call. And the third one is the definition of the function or called function. See, prototype is always written before the main, right like this. Before main function. Now function call is always right within the main. Now you should write within the main function. And definition function outside the main. Clearly, I want to explain here prototype of function and this is written in the before the main function. Before the main function means what is the first line of our C program? Hash include stdio.h header files. After header files, you should write the prototype of function or global variable declaration, right? And next one is the function call. Next one is you should take main function. That is also function. You observe here, main function. Main is a that system defined function. Like always, your execution is starts from the main function only. Clearly, right? Always execution is starts from the main function. And next, you declare the local variables. You declare the input output functions. If you have any content in the main function, you should write that content, right? And you should write the calling function. That is called the function call is written in the within the main function. And some other statements are there. And close the main function. And now we have to go to the definition of the function. Okay, you have a prototyping, you have a function call, and we want to go to outside the main function for implementing your calling function. That is called the definition of the function or called function. See, now how many steps are required to develop a function? One is prototype function, another one is the calling function, third one is the called function or definition of the function. Now, before the function is defined in the program, it should be declared. This declaration, prototyping means before the function. What is the before the function? Okay, before calling function, we should write the declaration, right? Or this will be written. This declaration should be above the main function. Already I mentioned above the main function area. The declaration should be written above the main function. This prototype provides information to compiler about the function such as a function name, number of arguments, and its data type. See, function name, what is the function name? For example, you write the function name is display. I want to write display, right? And a return type is, you take the return type, right? I want to use the void. Now, number of arguments. Now, int a, I want to take one variable. Int a, ending with the semicolon. Observe, the prototype is declared as void return type. Now, function name, number of arguments. That number of arguments are only one argument are required here. Now, int a, right. Now, ending with the semicolon. Now, coming to syntax, you observe here, return type either integer, float, character, or void. If you take void, there is no need to return any value from the called function to called function. And function name, argument list. Observe, function name, argument list. Here we should take the some arguments. Now, example for this one, add, add, the data type is integer, return type is integer. So you should return integral values only. Add, now the arguments are a comma b, because that function is the addition of two numbers. So we take the first integer and second integer. Now the prototype function is optional in C language. You observe here. In C language, suppose if you want to execute your program in C++ editor, we should write the prototyping is must. Otherwise, there is no need. Clearly, right? So the prototyping is written before the main function, right? A function call. Now, where we declare the function call, a function can be called on the name of the function. Such statements which contains the parameters, that is called the function call. So now in main function, we write the function name argument list. You observe here, students, before main, we declare the prototype. Okay, what is the prototype? In our previous example, int add, int a, comma, int b. This is return. And main method, open bracket. Okay, we declare a, comma, b. Suppose a equal to 10, b equal to 20. We assume. Now I want to use the add of a, comma, b. See, observe, add of a, comma, b. Now, where is the add? Here, add of a, comma, b. Now, the function call is written in the main function. Observe here, function call is written in the main function. What are the arguments we have? Argument list, that is a, comma, b. A which has contains some value, b which has contains some value. So it is nothing but add of 10 comma 20. Add up 10 comma 20. Close the comma statement for main. Now this is defining outside the main. This is defined. This is that is called the called function. This is the calling function. And next we write the called function. In called function, we are implementing the code. That is about the function call and function prototyping. Now we want to go for the definition of the function or called function. Now, definition of the function. So it contains the body of the function that performs the operations of the function. Okay, now we have to write the code for the function. Now, what is the previous function name? Addition. Add a, int a, comma, int b. Add a, comma, b. Now, what is the code for addition? Now, int c, you observe, a plus b is assigned to c. Now you print the c value. So a plus b is assigned to c is the code. That is the diff. That is written in the definition of the function. So now coming to here, this is the function void int add of int a, comma, int b. Now here I want to write int c, a plus b is assigned to c. You print something. Where you have to return the value from called function to calling function. So return type is must. Return type is the integer, float, character, double, log, log, log. Okay, now here return type is integer. So we should return only integral values. Right, clear guys? Now the one simple program, see the basic program. Now wide display, wide, you observe here, wide display, wide. So here, prototype of function, if you take wide, there is no need to return any value from called function to call to call, call to call. Now go to the main method. This is main function, display. So when you are using display function, the control is input from the calling function to called function. Why display? Now what is the code here? This is the display function. Clear? Now how many functions are declared in the main function? Only one function, that is display. So after this statement, the control is jump from calling function to this is calling function to called call function. Some implementation is there that after completion of this implementation, we come back to the main method. Now, the basic function types. This is very important for BTech and term exams. Now, basic function or sometimes it is called the inter-function communication. We have four techniques are there. One is the wide function without parameters, wide function with parameters, non-wide function without parameters, non-wide function with the parameters. Simply, we are called the technique like we write no parameter no return value. You write like no parameter, no return value. Wide function is no return value. You observe. Wide function is wide is nothing but a wide function means no return value from called to call. Without parameter means no need to send any values from calling to call function, right? And second one is wide function. See, wide function with parameter. It is nothing but a you write like no return value parameter, or you write like parameter with no return value, as you wish. Both are same. Parameter with no return value. Next, third one is non-wide function. Non-wide function, it is nothing but a return value. Return value without parameter. Without means no parameter. Now, next one is the parameter. Last one is parameter and return value. Return value. See, now I want to write the, see, I will take one example. See, first to design one, no parameter, no return. Second one is the Roma P for parameter, no return value. Here we have to send parameters from calling to call function. This is calling function. Calling function. These are the called functions. Next, third one. Fourth one. Yeah. Now, third one is the no parameter return value. No parameter return value. Return value means we have to send a value from called function to calling function. And fourth one is the bidirectional. This is bidirectional. Bidirectional means parameter return value or for return value. Parameter return value. It means, observe here, no parameter, no return value. It means now the function contains empty values because we don't want to read any value in the calling function because we are not sending any value from calling to call. So no need to read. Now reading, you observe here, the first method, first one, to design technique. In first design technique, read and print here only. First technique. Next, here. Reading is or read in calling function, print in called function. Why? Because there is no need to return any value. So after reading, these values are sent through the calling function. Now called function is receive these values and you do some operations on the values and print the output. Next. Now third one is the here reading is in called function, printing is print in calling function. We have to send, observe here, the arrow mark, observe the arrow mark. Values are send from called function to calling function. That's why you print values in the calling function. Like last one, read and print. Reading and printing both are in our main, that is called the main function is calling function. Because after reading, we send the values from calling to call function. That is the first arrow mark. After do some operations on the calling function, like these are all the operations. After operation, now return value is sent from called to calling function. This is about the basic designing approaches in our functions. First approach is the no parameter, no return value. Second one is the parameter, no return value. Third one is the no parameter, return value. Fourth one is the parameter, return value. Right? Now, coming to a simple example, first no parameter, no return value. Now, in our this is the prototype. Is there any parameters here? No. So that's why it is no parameter. Coming to main method. Add. Control is simple from calling to call function. No parameters, no return value is represented by function. Add. So it do some reading is here, printing is also here. Already we discussed. First approach. Read and print both are written in the called function for addition of two numbers. Next one. Next one is the parameter no return value. Observe here. You have to send some variable values from calling function to call function. So void int a comma int b. Now prototyping a comma b. To take some local variables that is called a comma b. You read a comma b, add of a comma b, add of a comma b. Immediately control is jumped from add function. For example, I want to read 10, 100 PHN. Now this is nothing but a add of values are 10, comma 100 semicolon. Now x is the formal argument. A is the actual argument. Now it is nothing but a 10 is assigned to x. Y is the formal argument. 100 is assigned to y. So x value is 10, y value is 100. So you take a local variable z, x plus y. X plus y, what is value? 10 plus 100. 100. This value is assigned to z. So you print z equal to 110. This is the parameter, no return value. We don't want to send any value from called function to called function. And third one is the no parameter return value. You observe here, we don't want to send any parameter from calling to called function. So these are the empty brackets. Observe. This is the empty because there is no parameter empty. Okay, we take one local variable that is for only receiving data from called to calling function. Add control. Now this is the add. So send control jump from calling to call function. ABC, you read a value. See observe. Reading is in called function. Printing is in calling function. Already we discussed. Now A is 100. B is 200. We assume 100 plus 200. Now 100 plus 200. 300. 300 is assigned to C. Now C value equal to 300. 300. Now this 300 is return from calling to called function. Now the 300 is assigned to M. Addition equal to 300. This is about the no parameter return value. And last one is the parameter and return. We have, this is called the bidirectional. We send parameter from calling to call function. At the same time, the output or some value is received from the called function to call function. Now, see, int a, int. So, how many parameters we have? Two parameters. So, we will take a two variables a comma b, and m for the we receive some value from call to call. Now we take 100 to 100. Add of is nothing but add of 100 comma 200. 100 to 100. Now control is jump from this line to int x equal to now what is x value? X equal to 100, y equal to 200. Add up 100 comma 200. Now this is 100 plus 200. 300 is assigned to z. So return z. Return z means 300. 300 is assigned to m. Assigned to m. Now m value equal to 300. Okay, the return value from called function to calling function. Now you should take the return value as integer. So 300, is it integer or not? Yes, it is a integer. It said only integer value here. If you want to take the character, then character is returned from called to calling function. This is called the inter-process communication or right functional designs. Already we have a diagram. You observe the diagrams. This is the second diagram. Downward is the second diagram. No parameter. See, parameter return value. Calling function here. This is the parameter. No return. Now this is the no parameter return. This is the parameter and return, both bidirectional. Okay. Downward, we send the parameters. Upward, we send a return value from called to column. And both bidirectional, send a parameter from calling to called function, receive a output value or some integer or some float or character value from called to calling function. The C language uses only pass by value and returns to achieve three types of communications between calling and call function. Okay, in addition of two numbers, we cover all the four modules, four designs, right? And now the next one is the how to pass array and how to pass the one dimensional, how to pass the two dimensional. See, this is the recursive call. Okay, now We will complete the how the arrays are passing, right? One second. Yeah, now we will see some programs and functions. Already we know the different four types of designs like interfunction communication techniques. One is no parameter, no written value, and parameter, no written value. And third one is no parameter, written value. And last one, parameter, written value. Now we will see the some programs, right? Like this. Write a C program to demonstrate designs. Action productivity IO dot. I want to take some example. Put the designs in one program, like local variables in a comma here wide add of int a comma int b. Now one is the no parameter, no written value. So no need any variable. You write printf no parameter and no written value. Int add of no parameter, no written value. Semicolon. Go to called function void add of take formal parameter syntax into all these things. Now here you read and print a comma def enter and b values. Take one more output variable, no need here, printf, or your interest, you take variable like a plus b assigned to c. Now, this is the simple program for addition of two numbers using with the no parameter, no written value. Now we don't want to send any parameter from calling to called function. We don't want to receive any written value from called function to calling function. Okay, now we save this program. NP, no parameter, no return value. So you take like this. Function design. Printf, where is the printf? Yes. Small error. Okay, compile and execute. Start waiting. Go to share. This is the no parameter, no return value. Enter A value 100, B value 300. Now you observe here, you read two values. One is A, another one is B. Now add equal to 400. This is the no parameter, no return value. Now I want to stop sharing. Go to program. We want to change the program. The concept is parameter, no return value. Already we discussed parameter, no return value means read the values in, we send some arguments in A into, just read the values in main method. Add of A comma B. Just we change this one. Now declare the output C. Enough. And formal arguments into, what is the variable? Already we have A comma to B. Either you take the A comma B is acceptable, X comma Y is acceptable. Formal variables, that's up to you. Take your own names. Not only take AB. Either you take AB, that is not a problem. That clear? Okay, now you have to save and execute the program. You observe here, this is the parameter no return value. Compile this program. No errors. Stop sharing. AB values 100, 200. The output is 300. So we pass 100 and 200 from calling to called function. Stop sharing. Now go to the program. Third technique. No parameter return value. Observe here. No parameter return value means now we want to remove the arguments. Return value is always some integer or float or character. No parameter. So we cut this statement here. No parameter, there is no values here. A comma B comma C. They remove this one. No need of all these arguments. Yeah, now C equal to add. Here you take one step. You compile and execute. Declare the variable. Then int. No error. Stop sharing. Go to share. Yes, A and B values. Some 500,000. The out is 1500. 500 is first value, 1000 is second value. This is the no parameter return value. The last technique, parameter return value. So parameter return value, you read and print values. Parameter return value, you declare some variables A comma B. Sorry, A comma B. Parameter, you declare the arguments into A comma into B. Return value is there, parameter and return value. Now, okay, done. Here, int A into B, int A comma into B. Int C equal to A plus B return. That's it. Okay. You read values, you read the variable, you print the output in main function only. C equal to add, sorry, A comma B. Parameter. Yeah, stop sharing. Go to program. Yeah, now I think it is visible. A and B values, you enter 200, 400. The output is 600. You return the 600 from calling function, called function to calling function. This is the 4 design techniques. And I want to explain one more program, new source file. Write a C program to find where the given number is, what is Armstrong or not. So go edio.a main. You take the prototyping int arm x main int f enter a number intensity percent n. You declare int n comma tempo. Now, temp equal to And here you take one variable r equal to ARM of M. If r equal to M, you write something now into ARM into M, open bracket, into REM, comma, sum equal to 0, but noted here. Now, REM equal to X mod 10. We find out the remainder here. Remainder and sum equal to for 3 digits. We find out the 3 digits. Sum plus REM multiply with 310. The next one is the X equal to X by 10. But here small error is there. While Mrs. while X not equal to 0, now here I want to write the return sum. So this is the module for the Armstrong. So here R equal to sum is assigned to R. In tab, the given percentage T Armstrong number, comma, tab. This is not chemical. Okay, we compile this program and run the program. Armstrong using the function tab, comma, R. Little small errors are there. Now there is no errors, so we compile this program. All of you look here. I want to share screen share. Yes. Is it visible? Int number. Number is 134. Number equal to 134. 134. So 134 is not Armstrong number. Is it clear? 134 is not Armstrong number. Already In last class, we discussed what is Armstrong number. Sum of cube roots equal to given number. What is sum of cube roots? 4 cube plus 3 cube plus 2 cube. 4 cube 64 plus 3 cube 27 plus 1 cube 1. 1 plus 28, 28 plus 64, 60, 84, 84 plus 90, 90 exactly. That is not Armstrong number. Or you better write here programming. I want to write. Now R equal to 10. So 133 equal to 134. Not equal. Save this function. Stop share. Go to module. Yes. Now I want to enter 126. 126 is not equal to value 6 cube. Okay, it is not fit in the value. Don't worry. I will show one more program. R value. Okay, R value and book are equivalent. Okay. Now we check this one. One 153. See this 153 equal to 153. So this is number is the Armstrong number. Okay, clear? Okay, now in this program, we pass one integer. Here we send only one integer. Now how can we send a group of elements? Group of elements means like arrays. Now I want to show one program using arrays. To new write a C program to pass only array. Now why we will find the sum and average. Sum of array elements int array sum a square bracket main. We declare array int a of 10 comma m comma y f enter number of elements. And percentage d comma ampersand f. Now we take You read the elements for I equal to 0, sorry, 0, I less than ఇట్లా ప్లస్ scanf percentage t ampersand a of I. Right. Now sum equal to s equal to, so you declare s here, s equal to arrays underscore sum a. We send base address only. Print array elements. That's it. Go to the called function in array underscore sum into x. And better you pass the n also. Yeah. Okay, now you find out the sum value into sum equal to 0, comma 5. Print sum of array elements are sum of array elements are I equal to 0, I less than n, I plus sum equal to sum plus a of sum equal to sum plus a of I. Return sum. That's it. Return. Save this program. Is there any errors here? You declare loop variable, you declare is x. Take yeah. Compare and run. Already near define reference scanf. Where is the scan? Of sharing. Go to share. See, now enter number of elements. We enter 6 elements. 12, 2, 32, 4, 7, 66. None more element 1. Now we pass group of elements from calling function to called function, right? Like number of elements are 6. we send 12, that is 12 to 33, 4, 66, 1. And we return the sum of elements like 180, 118. Clear? Is the program for passing one-dimensional arrays from calling function to called function. And now I want to take the two-dimensional array. Just I want to change the two-dimensional array int n comma int n. If it's matrix, better you write the n comma m comma I comma j comma. Now you write the trace of given matrix. Better here you write the trace of program. Take size of the matrix. J equal to 0, j less than semicolon j plus plus. Still want to change the, send the base address. The name also trace. Trace. Yeah, yeah. Sum equal to 0. Shortcut already we know. Better we write the j equal to 0, j less than n, j plus plus. If I equal to j, then y returns. Now just we change the two-dimensional array. One is we take columns. We had one more array, that is one more variable, loop variable chain, and on two-dimensional array we apply the two-dimensional array. Remaining all are saved, and you know the how to read and how to print the Matrix, better you print the matrix also. I want to write here. Print A comma N comma M. The matrix wide into E3 I. You declare the variable become format incomplete. Minimum we should take the columns. Go to share. And this is the matrix 2 by 2. We are entered to 3 by 3 matrix. We are enter elements 1, 2, 3, 4, 5, 6, 7, 8, 9. The matrix is 1, 2, 3, 1, 2, 3, 4, 5, 6, trace equal to 7. So, okay. Now, a little bit some error is there. I want to show the error. Number of rows and x equal to something. Trace a comma n comma m. Now the size of the matrix. No need all these values. Only column is enough. We will check if is there any error we can rectify. Why second row is not taking? Once again, we will see. Multiple times we declare the I variable. Okay, this is correct program. No worry. Okay, now it is the matrix. brace program using with the two-dimensional array, right? The next, we will see the pointers with the matrices. Already last video, I sent pointers with the 2D array, 1D array. Okay, just we have to change the code like you are add the functions. Okay, thank you all. Okay, if possible, can you please share to your colleagues, your friends, and subscribe these videos. Okay, these videos having good quality as well as good content. Thank you all.